Dear student, due to coronavirus, school started online classes for your study. So you can subscribe Golden Flower Palia YouTube channel, like and press the bell icon.
Hello students, today we are going to start the next topic of electric potential, that was to calculate the electric potential at any point due to electric dipole. Okay, so in this video we are going to discuss about the electric potential at any point. Okay, if the point is lying not lying at the axial position, it is not lying at the right bisector, now it is lying at any place of this dipole, and we have to draw the figure for that, and then we have to calculate for this. Okay, so now the potential at any point due to dipole. Okay, so now we have a dipole minus q and plus q, and this is the center of the dipole, that is O, and these are the point A and B, and the point in question at which we have to calculate electric potential, that is point P, not P, you take as N, which is lying at any angle. Okay, so here we have to draw a line from point O which meets point N. Okay, this line is meeting at point N and making an angle of theta with the dipole. Okay, this is dipole moment P. Okay, so let the distance of point N, it is R from point O, and to calculate the electric potential we need the distance of charges from the point in question at which we need to calculate the electric potential. So for that we have to join this point N with point B. Okay, with point B. Okay, so there it is. And we also need to calculate the distance of B to N and A to N. Okay, for that we are just going to elongate this line. We are going to increase this line, and here we need to draw a perpendicular from point A to this line. Suppose this is meeting at point D. Okay, and this angle, it is 90 degree. This is 90 degree. O to A, the distance is L. O to B, the distance is L. Okay. Similarly, for measuring the value of B to N, we also have to draw a perpendicular to the same line, okay, which meets at point C. Okay. If this angle is theta, this angle will also be theta, vertically opposite angles. So now we have these two perpendiculars, AD and CB. Okay, what to do with these perpendiculars? We just need to calculate this value, OC and OD. Okay, and for that we have to take one of the triangle. So OC is equal to OD. Okay, because all angles are same. Okay, they are congruent. So OC is equal to OD, and what will be the value of OD? If we see in any of the triangle, just take this one triangle AOD, and we want to calculate this value OD. Okay, and according to this angle OD is base, and OA is hypotenuse. This is a right angle triangle. OA is hypotenuse and OD is base. And with base and hypotenuse, because we are having the value of hypotenuse and we want to calculate the base, the value of base. So which trigonometrical ratio we have to take? So that we have to take cos theta. OC is equal to OD and they will be equal to L cos theta. Okay, they will be equal to L cos theta. And for that we have to take triangle. Taking triangle AOD, AOD is equal to cos theta will be equal to OD upon AO. OD upon AO. So OD will be equal to AO cos theta, and where the AO is L, so it will be L cos theta. Similarly, when we will calculate this value for this triangle BCO, the same value will come, that is L cos theta. So now we have the value of OC and OD, that is L cos theta. OC and OD, it is L cos theta. But what to do with this L cos theta? Because we need the value of B to N and A to N. So for this, what we have to do, the value of Bn will be equal to, the value of Bn will be equal to Cn. It is equal to Cn. That is why we have drawn the perpendicular. From B to C, we have drawn the perpendicular to make this distance equal to each other. So B to N is equal to C to N. And we have the value of O to N, that is equal to small r. Okay. So what is Cn? Cn is equal to On minus Oc. Okay. On minus Oc. And what is On? That is R. And what is Oc we have calculated? That is minus L cos theta. Okay. Similarly, the value of Am, the distance of minus q charge from the point in question. So what is Am? Am is equal to Dn. And what is Dn? Dn is equal to On plus Od. On plus Od. What is On? That is R. What is Od we calculated? That is L cos theta. So now we have the value of Bn and An. Bn it is R minus L cos theta and An it is R plus L cos theta. Okay. So now two distances we have calculated of charge plus q and charge minus q. So when we are having distances of the charges from the point in question, by applying the formula of potential, we can easily calculate the value of potential at point N. Okay. So here I am going to calculate now the potential due to plus q charge at N and then due to minus q charge at N. And the thing which you have to keep remember, that is due to positive charge, the potential at point N it is going to be positive, and due to negative charge, the potential at point N it is going to be negative. So potential due to plus q charge. Okay, plus q charge at point N. At point N. So what is the potential due to plus q charge at point N? That is V1 will be equal to 1 upon 4 pi epsilon naught, and Qy, and the distance of plus q from N it is R minus L cos theta. So R minus L cos theta. Okay. And due to minus q charge, V2 will be equal to 1 upon 4 pi epsilon naught, and it will be negative because it is due to negative charge, and this will be upon q upon R plus L cos theta. So now we have total potential and we need to calculate the total potential at point N. So net potential at point N, net potential at point and V will be equal to V1 plus V2. So value of V1 it is equal to 1 upon 4 pi epsilon naught Q by R minus L cos theta and minus 1 upon 4 pi epsilon naught Q by R plus L cos theta. Okay. So now we have total potential and we need to take something common. Okay. And then afterward we have to calculate this equation. Okay. So I'm going to remove this one. Okay. So here we have V is equal to Q by 4 pi epsilon naught, that will be equal to 1 upon R minus L cos theta and minus 1 upon R plus L cos theta. Okay, so we have the two values. Take LCM 1 upon 4 pi epsilon naught, that is R plus L cos theta minus R plus L cos theta. Okay, because here the minus sign we have taken, so this minus will be changed into the plus. R square minus L square cos square theta. Okay, taking the LCM. So what is going to be cancelled? R and R it is going to be cancelled. It is L cos theta, that is 2L cos theta. So here we can write it as 1 upon 4 pi epsilon naught 2QL cos theta upon R square minus L square cos square theta. Okay. So this quantity you are identifying that 2QL. What is that one? 2QL. 2QL is electric dipole moment, that is P. So in the place of 2QL we can write a P, electric dipole moment, P cos theta upon R square minus L square cos square theta. Okay. So for the ideal dipole, what will be the equation for electric potential? For ideal dipole, we are neglecting L square cos square theta in comparison to R, because the distance of point will be large and the distance between the two charges will be very small. So for the ideal dipole, we are neglecting this value in comparison of R square. So the final equation we will have 1 upon 4 pi epsilon naught P cos theta upon R square. So what to do with this equation? Using this equation, we can calculate electric potential at axial position, at any point which is present on the axial position, as well as we can find out the potential at the perpendicular bisector of the dipole. Okay, so two cases here we are going to discuss now related to this. So case number one, if point is at axial position. Okay, position, sorry. So if the point is present at axial position, that is in-turn position, if we are talking about the in-turn position, the first derivation of electric potential, so theta will be equal to, theta is the angle between the line which is joining the center of the dipole with that point and the line which is joining the two charges. Okay, so what will be the theta? Theta, for the theta, this is the dipole you have, and when we are talking about the axial position, the point is lying here, and the theta was the angle between this one and this one. So now this point is lying here, so theta will be equal to 0. Okay, so theta will be equal to 0, so cos 0 is equal to 1. So potential will be equal to 1 upon 4 pi epsilon naught P upon R square. Okay, it is same as we have calculated for the in-turn position. Now If the point is lying on the right bisector, that is case number 2, if we discuss here, on the broad side on position. Okay. If the point is lying at the right bisector of the dipole on the perpendicular which is passing from the center of dipole like this. Okay. So now the point is at angle of 90 degree. So theta we have to take as 90 degree. So cos 90 it is equal to 0. So potential will be equal to 0. This we have calculated, and in the last video lecture I taught you how to use this property in the numerical. Okay, so this much for today, and next in the next video we will discuss about equipotential surfaces and the properties of equipotential surfaces. Thank you very much.
Do self study at home and stay home, save lives.